Assalamu alaikum. Chapter 3 of Physical Geology, Matters and Minerals. Presented by Khalid Namrouni, PhD of Geology, Texas A&M University. And Khalid Namrouni is a staff member at the Department of Earth Sciences, Yunus University, Benghazi, Barga State, or Cyrenaica State. The reference used here is Essentials of Geology. This is the Department of Earth Sciences, Yunus University, and this is the main entrance of Yunus University. Here's the Prince Idris Senussi, the Prince of Cyrenaica State. And here's the flag of Cyrenaica State behind the Prince Idris, Prince of Barga. This is the capital of Cyrenaica, Benghazi. This is the chief commander of the Senussi Army, Omar al-Mukhtar, and this is the map of Barga State or Cyrenaica State. The outlines. We're going to study rocks, minerals, physical properties of minerals, crystal form, luster, hardness, and then we'll go through Mohs scale of hardness, cleavage, fracture, specific gravity, color, and streak. And then we'll go through rock-forming minerals, which are both silicate and non-silicate. And then through the silicate, we'll see two different types, ferromagnesian silicate and non-ferromagnesian silicates. And then we'll go through Bowen's reaction series, which is the sequence or studies the sequence of minerals crystallization from a magma. And then we'll go through the second part, which is non-silicate minerals, the carbonate minerals, calcite and dolomite, the other non-silicate minerals, halite and gypsum, and then common non-silicate minerals or mineral groups. Matters and minerals. A rock. Now definitions. A rock is an aggregate of one or more minerals. Some minerals commonly found by themselves in large quantities. For example, calcite. Those or gypsum. Those can be called minerals or rocks. A mineral or minerals are naturally, we have to have four conditions in any mineral. Naturally occurring, first thing. Inorganic solids, second. Third, possess a definite internal structure. And fourth, they have specific chemical composition. So, minerals are naturally occurring inorganic solids, possess a definite internal structure, and specific chemical composition. Now, physical properties of minerals. First one is crystal form. Crystal form is just the external expression of a mineral. What that external expression reflects, it reflects the orderly internal arrangement of atoms. Luster, the appearance or quality of light reflected from the surface of a mineral. And here we have to note that minerals that have the appearance of metal, like the shiny ones, we call them metallic. They have metallic luster, regardless of the color. Sometimes you find them like dark colors, but they are shiny. So we say these minerals have metallic luster. And the others that they're not shiny, we call them non-metallic. And they're described with various adjectives, including vitreous, glassy, pearly, silky, resinous, and earthy or dull. And some minerals, they're partially metallic, so we call them submetallic. So we have metallic, non-metallic, and submetallic. Regardless of the color, if they are shiny, metallic. If they are not shiny, non-metallic. Now, hardness. What's the definition of hardness? The resistance of minerals to abrasion or scratching. And here we have a scale, Mohs scale of hardness, and it goes or ranges from the softest mineral, talc, to the hardest mineral, diamond. And there are 10 minerals. You can use them in the field to help you. Talc, 1, the softest, in hardness scale is 1, and then gypsum 2, calcite 3, fluorite 4, apatite 5, orthoclase 6, quartz 7, topaz 8, corundum 9, diamond 10. And here you have to note that the hardness of your nail, fingernail, 2.5. So your fingernail can scratch, number one and number two can scratch talc, gypsum, but cannot scratch calcite. Calcite will scratch your fingernail. Copper coin, hardness scale is a 3. So copper coin can scratch calcite, gypsum, talc. And the piece of a glass, the hardness scale 5.5. So the glass can scratch apatite, fluorite, calcite, gypsum, talc, but cannot scratch orthoclase, quartz, topaz, corundum, diamond. And if it's hard for you to remember the arrangement of these minerals, there's uh, people they say the girl can flirt and other queen things can do. That tall girl gypsum can calcite, flirt, fluorite, and apatite, other orthoclase, queen, quartz, things, topaz, can corundum, do, diamond. Just to remember it. So metallic luster. This one is black color, okay, or dark color, but it's shiny, so we call it metallic, and the mineral is galena. Physical properties of minerals, continuous. Cleavage. Cleavage is the tendency of a mineral to break along planes of weak bonding. Minerals that possess cleavage are identified by smooth surfaces. So the breakish surfaces are smooth surfaces, which are produced when the mineral is broken. Fracture, on the other side, there are minerals like quartz, describe it, do not exhibit cleavage. So they don't have smooth surface, and therefore they say to fracture when it broke. Most minerals fractures are irregular. So the main difference between a cleavage and a fracture, when you break the mineral, if the surfaces of the breakage is smooth, we call them cleavage. If the surfaces are irregular, we call them fracture surfaces. Specific gravity is a number representing the ratio of the weight of a mineral to the weight of equal volume of water. So it's basically weight. You can estimate the specific gravity of minerals by hefting them in your hand, hefting or lifting them in your hand. So you can tell if it's heavy, light, and then color is very unreliable feature because any impurities can change the color of your mineral. Streak, the color of a mineral in its powdered form. So the color of the powder of the mineral. And here they have, in addition, metallic minerals generally have a dense dark streaks. Just a side note for the metallic minerals. And the non-metallic, they don't have this dark, dense dark powder. Here for colors, just this is the same metal, quartz, and it has different colors. So color is very unreliable feature to distinguish between different minerals because one mineral can have different colors. Depends on the impurities. Streak here, this is the powder of the mineral after so this powder color, dense dark color, this is metallic. Metallic minerals, they give dense dark powder. And a hardness scale, Mohs scale, he is just showing you the same scale, talc, gypsum, calcite, fluorite. It's just reversed from bottom to top. Apatite, orthoclase, quartz, topaz, corundum, diamond, and showing you the hardness, fingernail, 2.5, can scratch, 2 on 1. Copper, penny, 3.5, this is the copper penny here, can scratch, calcite, gypsum, talc, wire nail, this nail, 4.5, and glass and knife blade, this is knife blade here, and the glass 5.5, and then the streak plate, this is the streak plate, we use it to see the powder of the minerals. The hardness of it 6.5. so can scratch orthoclase down to talc. This is Mohs scale. Now cleavage, or the smooth surfaces when we break the minerals. Some minerals show one surface, one smooth surface, like muscovite. So they have one cleavage in one direction. This is numbered here, number one. This is the smooth surface when you touch it. Some minerals they show two directions, two smooth surfaces, like number one and number two. Here the mineral, number one, number two. And the degree between the two surfaces, 90 degrees. The example, feldspar. Some others, they show two surfaces, number one, number two, smooth surface when you fracture the rock. But the angle between the two surfaces is more than 90 degrees, 120, not right angle. There are some minerals give you three surfaces and others four surfaces. So the three surfaces here, the example is halite, and all these three surfaces, the smooth surfaces, when you fracture the mineral, three smooth surfaces, they have 90 degrees angles between the surfaces. And the example is halite. So calcite on the other side gives you three smooth surfaces, 1, 2, 3 here, 1, 2, 3, but the angles not right angles, 75 and 125. Some others give you four, like fluorite, 1, 2, 3, 4, and this is the crystal here, 1, 2, 3, 4, crystal of the mineral, four directions. So these examples of cleavage. So some minerals show one direction, one smooth surface, others two smooth surfaces, three smooth surfaces, and four smooth surfaces with variable degrees between the surfaces. The minerals that giving you a regular surface when they fracture, we call, when you break them, we call it fracture, not cleavage. Like, for example, here, conchoidal fracture in the quartz. The surface is very irregular. Can cut your finger if you touch it. Now, rock-forming minerals, silicate and non-silicate. Okay, for the two elements are silicon and oxygen, combined to form the framework of the most common mineral group called the silicates. So silicates group, or silicate minerals, made of silicon and oxygen, mainly. And there are other groups like carbonates, gypsum, halite are non-silicate. They don't have silicon in them, in their chemical composition. So let's look at the silicate minerals. Silicate minerals, the main fundamental building block is called silicon oxygen tetrahedron, and they can form single chains, double chains, sheets, and complex three-dimensional framework. So let's look at the figure to see the tetrahedron. Tetrahedron is just silicon, one silicon here. And let's go back here. And three ions of oxygen. Four ions of oxygen. 1, 2, 3, 4. This is silicon oxygen tetrahedron. Tetra, that means four faces. 1, 2, and the other one from the back, and the other one from the bottom here. 1, 2, 3, 4. Four faces. Four oxygens and one silicon. Let's look at the chains or the arrangements of these silicon tetrahedron. If you have single tetrahedra here, this will form, or you'll find this in the silicate structure. You find this in the olivine group. And if these tetrahedrons combined together will form chains. And the example is the pyroxene group, OGI. When this we call it single chain, and this, if we have another chain combined to this chain, will form double chain. We call this form double chain, made up of just tetrahedrons combined with each other in two chains. And the example is amphibolite group, and the mineral is hornblende. It's here in the picture, hornblende, augite, olivine. Olivine is very green here. And if the chains number of chains increased, we have more chains combined together that will form sheets. In the example, biotite, muscovite. And then if we have three-dimensional network, for example, quartz in potassium, and this is, we call it three-dimensional network. Also, we'll notice here, these minerals, olivine has iron, magnesium, pyroxene has iron, magnesium, amphipolar group, hornblende has iron, magnesium, and biotite has iron, magnesium. All of these elements from biotite up, the dark ones, always dark, we call them ferromagnesian silicate because they have iron and magnesium in their composition with the silicate. Okay, so these ferromagnesian silicate minerals, dark color, usually dark. The light ones, they don't have iron, magnesium in their composition. So these silicate, all of them silicate, but the upper group from biotite, amphibole, pyroxene, olivine, all of them ferromagnesian silicate. The other ones down here from muscovite, potassium feldspar, plagioclase, quartz, they are silicate but non-ferromagnesian. And this is the silicate minerals, ferromagnesium and non-ferromagnesium. Here there are some notes. The parallel lines called striations, distinguishing feature of the plagioclase feldspar. Quartz is the only silicate consisted completely of silicon and oxygen. The term silica is applied to quartz. Clays have a sheet structure. They make up a large percentage of the surface material we call soil. Just some other information to add. So now we know ferromagnesian silicate has iron and magnesium in their composition. Non-ferromagnesian, they have no iron and magnesium but still have silicate. Now parallel lines, striations. So we have two types of feldspar, potassium feldspar, the light color here, and plagioclase feldspar. Potassium, we call them orthoclase, and here plagioclase. Plagioclase, if you look at this here, you'll find lines, we call them striations. So this is how you distinguish between plagioclase and orthoclase. Plagioclase have striations, orthoclase no, they don't have any striations. And here we have some pictures for augite and hornblende. This is augite, dark color, ferromagnesian silicate, hornblende, ferromagnesian silicate. Now Bowen's reaction series. The sequence of minerals crystallization from a magma. So here what we have, let's read the figure. Temperature range. Here so high temperature, first to crystallize, first minerals to crystallize. And here low temperature, last to crystallize, last minerals. Inside here we have minerals. And on this side we have rocks. Rocks here, ultramafic, comatite, peridotite, basaltic, basalt, gabbro, andesite, andesitic rocks, andesite and diorite, granitic rocks, rhyolite, and granite, basalt, volcanic, gabbro, plutonic, andesite, volcanic, diorite, plutonic, rhyolite, volcanic, granite, plutonic. These mantle rocks. Okay, so let's look at the minerals. This side and minerals at this side. We find this chain is discontinuous and this arm is continuous. So this continuous series of crystallization and here discontinuous series of crystallization. Let's look at this. Olivine, the first mineral to form. And then when it cools down, the magma gives you pyroxene, and then amphibolite minerals, and then biotite, mica. At the same time here, calcium-rich plagioclase forms with the olivine and keeps forming plagioclase feldspar and changes from calcium-rich to sodium-rich down here. And as you go down, and these all dark or silicate, ferromagnesian silicate has iron magnesium silicate. As you go down, becomes non-ferromagnesian silicate, potassium feldspar, muscovite, mica, and quartzes. So if we look at the chemical composition, those are the last minerals to form. If we look at the chemical composition of ultramafic rocks, they should be within this box, this range: olivine, rich in olivine and calcium plagioclase. Basalt, basaltic and gabbro, rich in pyroxene, amphibolite, and calcium and sodium plagioclase with some olivine, but rich in these. Andesite, andesitic, which is andesitic rocks, andesite diorite should be rich in sodium plagioclase, some calcium plagioclase, a lot of mica, biotite, and a lot of amphibolite. And then we get to the granitic rocks, rhyolite and granite, very rich in quartz, muscovite, and potassium feldspar, and they form at lower temperatures. And might have some sodium plagioclase, some biotite, but very rich and dominantly rich with these quartz, muscovite, and potassium feldspar minerals. And as you go from top to bottom, you find rocks, minerals. They change from ferromagnesian silicate, dark colored, to the light colored silicate or non-ferromagnesian silicate. So darker rocks here, minerals, giving you darker rocks. And as you go down, lower temperature give you lighter rocks. Now, non-silicate minerals. They are economically very important, like carbonate minerals, calcite and dolomite. These minerals very similar, but you can distinguish between them if you use dilute hydraulic acid. Calcite will react fizz vigorously with this acid, where dolomite will react only when powdered. Okay, how we name these carbonate minerals? If calcite more than dolomite, we call it this rock, we call it limestone. If dolomite percentage more than calcite, we call the rock dolostone. There are other non-silicate minerals like halite and gypsum, and these minerals form during evaporation of the oceans. Now we have common non-silicate minerals or mineral groups. We have native elements like gold, copper, diamond, sulfur, graphite. Notes diamond and graphite, they have the same chemical composition, carbon-carbon, but the structure is different. Oxides, hematite, magnetite, corundum, ice, which is H2O, water. Sulfides, galena, sapphirites, pyrite, chalcopyrite. We have sulfates, gypsum, hydrous calcium sulfate, and hydrite calcium sulfate. They have the same chemical composition except gypsum has more water, has water, and halite is dry. Halites, we have halite and fluorite. Carbonates, we have calcite, dolomite, and we have malachites. And this, well, the take-home message, we did rocks, minerals, and physical properties of the minerals. We find minerals, they have crystal forms, they have luster, hardness, which is most scale hardness, cleavage, fracture, specific gravity, color, streaks. And we talking about rock forming minerals, we find them silicate and non-silicate. The silicate that made up of silicon and oxygen, and the silicate, silicon and oxygen, sorry. And the silicate are divided into two parts: ferromagnesian silicate that have iron and magnesium, besides the silicate, and the non-ferromagnesian silicate that have no iron and magnesium in their chemical composition, just straight silicates with other elements, minerals. And then we talked about Bowen's reaction series that talks about the sequence of minerals crystallization from magma. And then we talked about the non-silicate minerals like carbonates, calcite dolomites, and halite and gypsum. And then the common non-silicate mineral groups. And this is will conclude the lecture. And now we'll take 3 minutes rest and listen to the national anthem of Cyrenaica.
أفرف كأجنحة النسور فوق الشواطئ والقصور فلك المراكز في الصدور يا أيها العلم النظير يحيى الأمير يحيى الأمير أفرف فأنت شعارنا وإلى الأمان منارنا بك أملت أبصارنا وإليك بالفخر نشير يحيى الأمير يحيى الأمير إن الهلال مبشر والنجم عبد نير أما السواد مذكر ولطال من تبع الذكير يحيى الأمير يحيى الأمير إدريس أنت أميرنا إنا لنوك فثق بنا لبيك يا رمز المنى في أي ناحية تشير يحيى الأمير يحيى الأمير نحن الشباب النابضون وإلى المفاخر راكضون بالأمس جاف رابضون واليوم قد آن المسير يحيى الأمير يحيى الأمير العلم نور حياتنا والدين خير هداتنا والصبر سور صفاتنا والله مولانا النصير يحيى الأمير يحيى الأمير.
Thank you very much.